Okay, I'm really excited about this extra credit assignment, solving equations involving logs. So I'm going to go ahead and walk you through multiple examples. And then in the second video, I'm going to give you the problems that you need to solve. So let's go ahead and get started. So first of all, in order to solve this equation for x, there's a property that you need to know, and you need to know that the natural log of x, okay, is equal to log base e of x. That those are equivalent statements. So when you have a natural log, you have base e, okay? Also, converting from logarithmic form to exponential form. So in order to convert this to exponential form, we start off with the base, which is e, because it's a natural log. Natural log always has base e. And then we're going to raise that to the exponent, which in this case is y. And we're going to set that equal to the argument, which is x. Okay? Another way of converting this would be cancel out the natural log by raising both sides to base e. So this would cancel this out because the bases are the same. And we would have x equals e to the y, which is what we got here. This method here is probably going to be the most useful method. All right, so back to the problem. We're trying to solve for x. So we're going to start off by dividing both sides by 3. Okay, and then we want to cancel out the natural log. So since it's base e, I'm going to use this method right here. I could use this method as well. And so we get x equals e to the third power. And you can leave your answer like that. We've isolated the x. Okay, example 2. So in this problem is very similar to the previous problem. We've isolated the natural log on the left. So all we need to do is cancel out that natural log. So we end up with 2x equals e to the 5th. Divide both sides by 2. And there is our answer. Or you could write that as 1/2, because there's a 1 in front of here, 1/2 e to the 5th. Same thing. Okay, example number 3. Okay, so here's one where we have to use our property of logarithms. Remember that when you're adding logs, you multiply the arguments together. So in this case, this is going to be the natural log of x cubed. And since we have a log isolated over here, we can cancel it out. Base e. So we have x cubed equals e to the 3rd. And to cancel out the 3rd power, we raise it to the reciprocal. And we get x equals e. Moving along, number 4. Okay, so we want to solve for x. First thing we want to do here is one of the properties you need to know for this type of problem is that the natural log of e to the x equals x, because the natural log of e is 1. We'll move that x down front here like this, and the natural log of e is equal to 1. We'll write that up here, because e to the first power is equal to e. So x equals x. So knowing this now, we know that this natural log of e is going to cancel, leaving us with the natural log of x. Okay, using our property of logarithms, we know that subtraction means to divide. And since we have a natural log on both sides, we can raise both sides to base e. So that's going to leave us with equals 2. And from here we're going to cross multiply. So x times 1 is x. 2 times x minus 3. 2x minus 6. Solving for x. Cancel, cancel. We get x equals 6. And don't forget to check your answer when you're dealing with logarithms, because if you plug a 6 in, 6 minus 3 is 3. Remember, the argument has to be positive, which in this case it is. Okay, next problem. All right. Using our property of logarithm subtraction, this will condense down to division. We have a natural log on both sides, so we can cancel them both out with raising it to base e. And I'm going to set up a proportion, so I'm going to put that over 1. Cross multiply. Notice that these two groups are getting multiplied together, so I put them inside grouping symbols. Okay, and 5 minus x times 1 is 5 minus x. I'm going to go ahead and FOIL this. So first terms, 1 times negative 3. 1, that's your first terms. Your outer terms, that's going to give us negative x. Our inner terms is going to give us 24x. And our last terms is going to give us 8x squared. So we want to solve this for x. I see that it's a quadratic, so I have to set this equation equal to 0. So I'm going to go ahead and 0 out the left side. So that's 0. And this is going to give us negative 8. Those will cancel. All right, so this kind of looks strange here, so I'm going to go ahead and turn it around. Put my square term first, so that we're in standard form. And we have a quadratic, So I'm going to go ahead and try to factor this first, see if it's factorable. So I see that 8 goes into all three evenly, so I'm going to factor out an 8. Okay, so this factor will not give us a solution because it does not have an x. So I would like to try to factor this, but as I can see, it's not factorable. So we go to our handy-dandy quadratic formula. So our a value is 1, our b value is 3, our c value is -1. Plugging it into the quadratic formula, x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. It would be a great idea to have that quadratic formula memorized. Okay, let's go ahead and simplify. So we're going to have 9. A negative times a negative is a positive. So 9 plus 4 times 1 times 1 is 4. 9 plus 4 is 13. Over 2 times 1, which is 2. I could put this in my calculator and get my 2 decimal approximations here, because it might be a good idea, because we would want to plug them back in for x into the original equation to make sure we don't have a negative log. So let's calculate that real quick here. Let's just make sure. So one of the solutions is 0.302776. Okay, that's doing the addition. So then I'm going to go back up here, arrow up, press enter, and change this to subtraction. And divide that by 2. So the other possible answer is -3.30278. So, checking our answers, first one, 0.302. If I plug that in here, this will be positive. And plugging 0.302 in here, that is going to be negative. So what that tells me is that this answer here does not work, because when you plug it in here, you get a negative argument. Okay, let's try the other one. So -3.3, plugging that in here, we get 5 minus -3.3, which is 8.3. That's good. And then -3 minus -3.3, that will give us a positive argument. And then plugging it in here, that's going to be 1 minus 8 times -3.3, which will give us a positive argument. So our solution is going to be that answer. Remember, you have to plug it in for x. Make sure this is a positive number. Plug it in for x. Make sure this is a positive number. Plug it in for x. Make sure it's a positive number. If it's negative, then it's an extraneous solution, and it does not work. Okay? All right. So on part 2, I'm going to do a few more examples, and then I will give you the problems for you to work on.